Evet, geldi.
Uygunsa hocam başlıyorum.
Ama başlayabilirsiniz.
Ee,
Hello everyone. My name is Mert Durgut. I'm a PhD candidate in the field of Management Information Systems at 9 Eylül University, İzmir. We are pleased to present our proceeding with the title of A Bibliometric Analysis of Cloud Computing and Business Intelligence. In this paper, we present a bibliometric analysis of cloud computing and business intelligence to map the research landscape, identify the trends, and highlight the most influential scholars and publications in this field for the filtered scientific research. The outline of our presentation will be as follows. I will start with purpose of the study. Then I will briefly present the literature studies. Firstly, literature review, cloud computing, and then I will continue with business intelligence, bibliometrics, and bibliometric analysis. After that, the methodology of our study, and finally, I will present the findings and conclusion. The goal of this research is to review academic studies on cloud computing and business intelligence topics that were published between 2017 and present, both separately and together. And the targeted analyses are like these. Frequency analysis of the publications on which these two subjects are studied jointly by years for both terms cloud computing, business intelligence, and the studies they both exist. Word cloud of keywords in the studies, relation between authors who cited each other, and most cited works. After talking about the purpose of the study, let's move on to the literature section a little bit. First of all, when we look at the literature on cloud computing, the points we want to emphasize are as follows. In the literature, many definitions of cloud computing have been put forth. While most of these findings are in agreement, it would be beneficial to highlight one noteworthy definition. The definition of National Institute of Standards and Technology, NIST, about cloud computing is cloud computing, a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimum management effort or service provider interaction. And now I would like to talk about the historical development and emergence of the concept of cloud computing. The concept of cloud computing dates back to John McCarthy's work at MIT in 1961, saying that in case computers of the kind I have pushed ended up the computers of the long run at that point, computing may someday be organized as an open utility fair, as the phone framework may be an open utility. The computer utility might gotten to be the premise of a unused and vital industry. While cloud computing's foundations date back to the 1960s, the real provision of cloud computing services arrived considerably later. In this view, the first real cloud computing service, Amazon S3, was introduced in 2006. The true innovation, though, was the pricing mechanism created for S3, which is currently the industry standard for cloud service pricing, pay as you go. Now let's continue with the concept of business intelligence. IBM researcher Peter Loon is the first person to use the concept of business intelligence, and his words about business intelligence are as follows: the ability to make sense of the relationships of available information to achieve a desired goal. The notion of business intelligence becomes significant because of its numerous implications. Data has to be transformed into an appropriate format in order to facilitate strategic planning and decision making. Strong analytical tools such as visualization and data mining tools are provided by business intelligence. These tools assist users in making wise decisions and improve their user experience by taking it to a higher level. And when we look at the visual on the slide, we see business intelligence elements such as business performance management, data governance, data architecture, data integration, business intelligence program, and data warehousing. Let's continue with bibliometrics. The definitions made about bibliometric and bibliometric analysis are as follows. Definition of bibliometrics is the study of publication trends through statistical analysis is known as bibliometrics, which encompasses a wide range of rules and procedures. And bibliometric analysis is the numerical investigation of the distributions created by people or tech in a certain period and in a certain locale and the relations between these distributions. Now it's time for the methodology of our study. The bibliographic analysis conducted within the parameters of our study was conducted using the WOS Viewer program. In addition, the publications to be examined within the parameters of the study were retrieved from Web of Science Index. The filters used for the selected studies are as follows. Publication language is English. Publication type, articles and review articles. Publication date range 2017 to present 2023. Publication filter in Web of Science, business intelligence and cloud computing patterns in the title, introduction, or keywords sections of the studies. A column chart was created by analyzing the frequency analysis of the studies that combined the terms cloud computing and business intelligence, both separately and together. The analysis was done according to the years. One of the goals of the analysis was to create graphs for the most cited studies. The generated graph is a funnel chart creating Microsoft Power BI, in addition to graphs that are accessible as a feature on Web of Science. The keywords found in the filtered studies of the analysis were combined to form a word cloud using Python language and the word cloud library, and the word cloud was generated. When we look at the graph in upper right, the number of studies that include the term business intelligence as a keyword does not exhibit a consistent upward or downward trend. Still, the rise in 2020 is remarkable. When we come to the graph in the bottom left, while the number of studies using the term cloud computing as a keyword appears to have stabilized in 2022, it has been steadily rising over the time. Let's continue with the next slide. Now, when we look at the graph on the top right, upon reviewing the studies that combine these two terms, it can be noted that there are typically few publications, Highest number of publications were in 2021 with 14. There hasn't been any consistent change in the quantity of publications over the years as of yet. And when we look at the graph in the bottom left, one publication came to the forefront with nearly twice as many citations as the second publication, which received 151 citations overall, while the most cited publication received 288 citations in total. And now we have come to our last slide about the findings. When we look at the graph on the top left, upon examining the relation analysis about publications featuring common keywords, the terms big data and cloud computing emerged as key terms associated with the study. In this sense, big data is the phrase most frequently linked to these two keywords. And finally, when we look to the word cloud on the bottom right, as we might expect, the terms cloud computing, big data, and business intelligence stand out when we examine the word cloud created from the keywords of the studies that were looked at. And here are references, and thank you for your interest.
Thank you for presentation.
Thank you.
Do you have any question? Okay. Thanks again. Next presentation. Dear Muhammed Gabriel. Dear Gabriel, you can start.
Can you hear me?
Yeah.
Good morning, everyone. My name is Mohammed Gabriel. I'm a medical chemist from the University in Turkey. I'm very pleased to present our research for our review research today, which titled the comparative study on feature descriptors in video augmented step of estimation. As you know, localization and state estimation is one of the most important and most critical problems in estimation and validation for robotics, specifically the performance driving cloud. Integrating visual augmented system to our localization stack beside the initial measurement unit and can help us in GPS remote environment to handle the ambiguities. But in visual augmented system, we have a lot of problems to solve, and we are going to discuss how to build a robust system for visual augmented in our presentation that can help us deploy more lightweight feature descriptor algorithms. As you know, in real time, real world applications, our accuracy, the accuracy of the algorithm is not the most important metric how to choose an algorithm, but also the computational cost of the algorithm we are going to do. And we are going to use a simple simulation using the Parla simulator for explaining how we can conduct or redo our techniques we are going to
Dear Gabriel, dear Gabriel,
Oh, my connection is what? Can you repeat again? I'm going to talk now about our building blocks for a robust visual notice system, the visual notice stack for this installation. The first thing we're going to do is defining the camera sensor. We are utilizing the pinhole camera model, which is a very simple model, but working very well in practical applications. The camera projected geometry, transforming any point from the world coordinates to the distance coordinates, and handling the problem of closing the third dimensional information when going from the camera coordinates to the image coordinates. Of course, we are still dealing with the pinhole camera model, and then bring camera calibration to get the intrinsic and extrinsic camera parameters. In our research today, we were especially interested in the intrinsic parameters, which denoted here by the K matrix, which is a 3 by 3 matrix. Then our image features and feature vector, it's gonna be detected as a distinct location in the image. Of course, as you see here in the image on the right, the corners, you have gradients in two dimensions instead of one dimension as you have an edge, which can be more distinct and more easy for our algorithms to detect from an image. The next step is to describe our feature. There is a lot of feature descriptors like set, serve, leave, hold, and risk. We are going to talk especially here about the set and leave algorithms. The set algorithm, which is the abbreviation for the scale invariant feature transforms, is a well-established feature descriptor, which is widely used in a lot of state-of-the-art systems. It's going to give us a factor of 128 dimension that give us a signature of the structure of the feature are detected to be able to describe it and using it afterwards in matching our feature. Our binary descriptors are more compact. They are more compact descriptors, fast to compute, and trivial and fast to compare compared with the set descriptor, but suffer from a huge problem, which is the end-to-end efficiency. We'll talk about how we'll discuss how to solve this problem in the next slide. The most famous binary feature descriptor here is the brief feature descriptor, and this will play a huge role in our simulation in this study. For the feature matching step, There is two main approaches here. The most basic approach is the brute force feature matching algorithm, which is simply trying to match every feature in the frame k-1 to the feature in frame k, which can be very slow and slow in our computations, especially if you have a lot of features reflected in our images. So utilizing something like the KD trees data structure can help us accelerate our matching processes. Then our next step is a very important step, which is the outlier reduction. Outlier reduction can be done using the Ransack model. It's a very simple technique to handle ambiguities and outliers in our matches, and a lot of implementations are there in libraries like the FNCB. The the last step, or the most important step, I can say, is the trajectory estimation, where we estimate the position and orientation of our vehicle by analyzing the changes in the camera images captured while the vehicle is in motion in the environment. And this is done to explicitly give the rotation and translation metrics and vector between two image frames. This is done by using the two most famous techniques in this field, which is the PNP, or the prospective endpoint algorithm. This is really the one we want to estimate the transformation from 3D to 2D planes. This can be done only if you have a depth map or a frame estimation, if you are using unmanned aerial vehicle. If we don't have this information prior to our work, we can use the essential matrix method, which is used to get the 2D motion estimation. And for PNP, there is a direct solution by Brunner, which I think in the 19th century, and it's working very well in this field right now. Although there is a lot of solutions using the machine learning techniques. Our evaluation results are in front of us now using the set algorithm, which is, I can say, the most important, the most popular feature descriptor in this field. But due to its computation time, it's very hard to deploy it in a lot of real-time applications due to the high computation cost it has. And we can infer here the brief algorithm after building a robust visual augmented system can be used, especially in self-driving cars, where we don't have a lot of implementations. The brief algorithm can work very well, as you can say. Last word here, we can say that building a well-engineered visual augmented system can help us utilize lightweight feature descriptors like the brief feature descriptor, using some good feature descriptors like the sensor or the star feature descriptor, with the emphasis on using them in real-time or real-world self-driving scenario, where there is where we cannot have a lot of implementations. Maybe it is not working well in photogrammetry or in cinema. I can think. I can say, because we have a lot of implementations, and this is a very weak point in the brief feature description. But in real world self-driving applications, the brief feature descriptor can be utilized and deployed in real world real-time applications. Thanks for listening.
Thank you for presentation. Next presentation, dear Ahmet. Ahmet Al-Jumaili.
Hello, everyone.
Hello, you can start.
Hello, everyone. My name is Ahmed Al-Jumaili, PhD student in Safakis University. Tomorrow, we talk about a review on secure authentication protocols in Internet of Vehicle algorithm and protocols and comparison. Outline introduction and Internet of Vehicles system include architecture, authentication protocols, and lightweight cryptographic protocols in Internet of Vehicles. Internet of Vehicle security attack and comparative study, computational overhead and security and functionality features comparison, and challenge and features research and conclusion. Contribution. This paper provides a concise yet thorough examination of the overchange design, encompassing analysis of the authentication and Internet of Vehicle system, alongside an exploration of the lightweight cryptographic protocols employed. The investigation of potential security vulnerabilities in Internet-connected vehicles. The characterization of key management authentication, intrusion detection, access control, and privacy provision, along with other security mechanisms employed to safeguard data in the Internet of Vehicle. Within the realm of the Internet of Vehicle, our attention is directed towards the multitude of authentication techniques necessary to establish secure communication among the diverse intents involved achieved through the process of mutual authentication. Furthermore, we do a comparative analysis of their respective costs, taking in the consideration supplementary criteria such as functionality, security, and processing speed and communication. Introduction. As the Internet of Vehicle progress, it's become imperative for intelligent transport system to incorporate mobile cars equipped with the Internet of Things. The Internet of Vehicle technology enables vehicles to establish communication with each other outside unit and cloud server through a suitable internet channel. The feasibility of this is facilitated by a diverse array of communication protocol encompassing with the Wi-Fi and Bluetooth and cellular network and dedicated short-range communication. The cost effectiveness and reliability of cloud computing as data processing solution render it very suitable for the implementation of Internet of Things and Internet of Vehicle deployments. The utilization of Internet of Vehicle technology has the potential to mitigate traffic congestion, enhance road safety, and minimize emission through various means such as route optimization, ideal term reduction, and the formation of electrical and hybrid vehicles. The emergence of 5G and beyond networks and subsequent advancement are integrated to facilitate the expansion of the Internet of Vehicle, thereby enabling quicker and more dependable connectivity between vehicles and roadside units. However, the widespread adoption of the Internet of Vehicle technology has various problems that must be addressed. It is imperative to ensure data privacy and security, transparency, vulnerability, scalability, and integrity among the intents involved. Additionally, it is a circle to addresses infrastructure and regulatory difficulties as well as effectively manage the complexity associated with integrating multiple technology and device. Internet of Vehicle System. The Internet of Vehicle System is a connected ecosystem that integrates vehicle infrastructure and various communication technology to enable intelligent and efficient transportation. It involves the use of advanced technology and communication protocols to enhance safety, improve traffic management, reduce congestion, and provide a seamless driving experience for users. Here are the key components and characteristics of Internet of Vehicle System. Include vehicles and infrastructure and communication technology and vehicle ad hoc network and data exchange sharing, intelligent transport system and security and privacy, autonomous and connected vehicles and cloud computing and big data analysis and smart service and application. Internet of Vehicle architecture include infrastructure, roadside unit, users and vehicles, and the cloud servers and trusted authority. We show a connected between vehicle to vehicle and vehicle to roadside and roadside to infrastructure and infrastructure to cloud server. Internet of Vehicle authentication protocols. The aim of implementing security procedures in the Internet of Vehicle is to ensure a safe and secure environment to vehicle communication and communication between vehicles and the central management. Figure 2 classification of authentication protocols divided in 3 parts: signature and cryptograph and variation. A cryptograph includes symmetric key and asymmetric key identity based. Lightweight cryptograph protocols in Internet of Vehicles. To protect the security and privacy of connected vehicles and their users, lightweight cryptograph protocols are essential. Several types of lightweight cryptograph protocols are commonly used in the Internet of Vehicle environment, such as secure hash algorithm, advanced encryption standard, and data encryption standard, elliptic cover cryptograph, and transport layer security, lightweight cryptograph, and zero knowledge proof. Internet of Vehicle security attack divided 4 parts: authentication and availability and confidently and integrity. Authentication include rival attack, spoofing attack, physical attack, intrusion attack, cyber attack. To solution this attack, we use this solution for any attack in the authentication. Availability include denial of service attack and jamming attack. Confidently, man-in-the-middle attack, eavesdropping attack. Integrity include 2 parts: malware attack and misguiding attack. Comparative study. This section compares the effectiveness of the current lightweight authentication schema in the Internet of Vehicle. In my work, 60 references were taken to compare them. Table 2 shows in the research category and concept applied and network model, phase and benefit and limitation. Confidential overhead. The communication cost of various schemas is listed in table 3 to access the calculation overhead throughout the authentication and key agreement phase based on the result of previous experiment used in the reference 71. Table 3 listed as a cryptograph function used in the previous Internet of Vehicle lightweight authentication schemas along with an estimate of execution time. Table 3 include cryptograph operation and sample and costs in the millisecond. Table 4 compare the communication cost details, include the number of message and storage cost of our schema with this of the existing models. We note the high bits used in the reference 68 4032 and connected message 6 equals 6. In the table 5, we have compared the computational cost of the authentication frameworks suggested by reference 47 Hassan to 72 Fasuda and Nong Thimpam. Suggested method have reduced computing cost but lack security and functionality and have high communication cost. In figure 5, we note that reference 72 is low cost equal 0.76. Security and functionality features comparison. The functionality and the security characteristic of various methods are compared in table 6. Nongthong schema reference 72 provides more security and useful features than other plans do, as shown as in the table 6. Challenge and feature research. Authentication protocol in the Internet of Vehicles face several challenges, and ongoing research is focused in addressing the challenge and exploring features advancement. Include user experience, trusted management, scalability and resource constraints, and security privacy and interoperability. Conclusion. The emergence of communication protocols for autonomous vehicles presented new opportunities for investigating and improving the security and privacy capability of the Internet of Vehicle networks, aiming to safeguard the confidentiality, integrity, and accuracy of transmitted data. The safety, privacy, and life of these inside vehicles are suitable to a diverse array of security and privacy risks, hence necessitating a primary focus in security measure. The Internet of Vehicle as emerging network paradigm is accepted to encounter heightened challenge attributed to the escalating significance of ensuring secure connection. There exists of significant demand for the development of increasingly sophisticated model structures and repeat real-time authentication mechanism. One potential feature problem involves the acquisition of cures of vehicles location data and subsequent utilization of increasingly sophisticated data management operating system for processing side information. References. Thank you for all.
Thank you for presentation. Do you have any
Thank you for all.
question? Okay, next presentation, dear Sue.
Yeah. Dear colleagues, conference participants, we are pleased to take part in the second International Symposium on multidisciplinary studies and innovative technologies. Our research is devoted to computer mathematical modeling of the influence of the macro environment on the economic behavior on the enterprise. Let me present our research. In the economic of Ukraine, after long reformation, crisis and post-crisis periods, there has been a fundamental change in the conditions of the functioning of economic entities. As a result, there has been not only a transformation of the economic landscape, but also a change in the priority of traditional problems for domestic enterprises, such as no payment, lack of working capital, arrears of wages, lack of solvent demands for industry products, as well as the emergence of new trends, political and economic instability creates a situation where the influence of the external environment on the activity of engines of economic relations takes the priority and justifies the relevance of further research in this direction. At the same time, the main problem remains the assessment of the influence of the complexly structured external environment in which the enterprise functions, led to various types of its economic behavior. Thus, the issue is effective management of the economic behavior of enterprises in the conditions of statistic of their market activity. In this, the focus of research by both foreign and Ukrainian statistics and practitioners. This economic behavior of the enterprise is a combination of market operations and managerial reactions. Its effectiveness is determined by many factors of the external and internal environment, which must be properly monitored, evaluated, and modeled by use model computer tools and information technologies. Therefore, the most important test of enterprise management is to develop of the decision-making support system for managing the economic behavior of the enterprise. This work suggests the following structure of model-oriented decision support system, DSS, slide 1. Based on the purpose of the research, we will consider in detail and the component of the DSS database for managing the economic behavior of the enterprises, a subsystem of the external environment. The external environment of the enterprise is a complex structured system, which include 1. A general macro environment, the changes of which reflect the general trends in the development of the national economy and to which all agents of economic relations can only passively adapt. 2. The immediately economic environment, the changes of which are predicted by the behavior of the enterprises and to which the activity adapt. Therefore, a subsystems of macro environment database should include a justified list of indicators that, on the one hand, allows you to determine the general trends in the development of the national economy, and on the other hand, to highlight the characteristics, feature, particularities of types of the economic activity to which a certain enterprise belongs. This will make it possible to form a system of achievable and effective solutions, taking into account the enterprise's resource capability when development of the enterprise's management response to external environment disturbances. The constructions of the database of the external environment subsystem is based on following hypotheses, namely, one, statistical information must be reliable, accurate, comparable, relevant, and responsivity. The information space of the indicators should be for the achievement of research goals and the formation of the DSS of economic behavior management. Through the system of the indicators should enable the researcher to gain new knowledge about the process of economic behavior of the enterprises, both from a systemic point of view and to identify specific feature of the behavior of an individual enterprise. It was this hypothesis that were the basis of the creation of the research information space. The following algorithmic model has been developed to analyze and model trends in development of the national economic as business environment. Let's take a closer look at it. Step 1. Construction of the information space for assess and analyze trend in the development of the national economic. And this step form a list of indicators and accordance with the factors and the general ethno-macroeconomic and the immediate environment in which the enterprises operate. A comparative monographic analysis is exciting approach made it possible to propose the following system of assessment indicators: general macro environment, gross value at basis price, gross domestic product per capita in current process, apex impact, not net foreign direct investment in current process, inflation rate, unemployment rate, consumer prices index for goods and service, immediately environment, number of active business in entities, number of persons employed by business entities, turnover of business entities, net profit of enterprises, profitability of the operational activity of enterprises. The proposed list of indicators forms the information space for assessment and analysis of the economic behavior of the enterprise under the condition of its passive or active adaptation to changes in the complex structure international external environment. Step 2. Modeling the external environment of the enterprise. To build a general model of the external environment and model of the macro environment, economic and immediately external environment. Its purpose to use the text taxonomic method of the level of development. To choose of this method is justified by the fact that its integral indicators accumulate the synergistic effect of the various indicators and allows to characterize the economic behavior of the enterprise from a systemic point of view. The indicator value is anomalous and varies in the range 0 to 1. The economic interpretation, the values of the integral indicator is as follows. The closer its use is to 1, the more stable is the economic behavior of the enterprise. The formal view of the model is on the flows percent on slide 4. Calculations were made is statistic
Dear Sue, dear Sue,
Maybe I can continue
can you continue, dear Olha?
this presentation, information for this presentation. So problem with maybe internet.
Okay.
Conclusion were made in the statistic environment for the period 2010-2021. The calculation results are given in slide 5. Analysis of the data allowed us to draw the following conclusion. First, trends in changes of the values of integral indicators have on non-line wave-like characters that reflects the changes in the stability of the external environment in which Ukrainian enterprise operates. The local minimum point for the general integral indicator of the external environment is 2015 respondent of the political changes in the society in 2014, the revolution of dignity. This caused a high level of instability in the external environment of all economic entities, with significantly reduced the economic activity. Until 2014, there was an excess of the values of the integral indicator of the macro environment are the values of the intimate environment. Stating from 2050, the situation has changes and two periods can be distribution. The period of the predimension of the influence of the intermediate environment over the macro environment, the period 2015, 2017, and 2021. The period of almost indicative influence of local integral indicators of the economic behavior of enterprises. This analysis provides information for the development of effective management, decision of the economic behavior of an enterprise by using passive and active adaptation tools. To determine the dominating influence of local factors of the general macroeconomic environment of the enterprise, a model was developed. The results of calculations, the parameters of which are present on slide 6. The quality of the model is high, to which it confirmed by the values of the correlation and determination 0.998 indicators respectively. Thus, the economic mathematical model of the influence of macroeconomic and the intimate environment factor on the overall stability of the enterprise macroeconomic environment has been presented in the slide 6. The obtained model is used in forecasting the level of instability of the general external environment, which directly affects the information of management decision of the economic behavior of the enterprise. In addition, the analysis of the calculated parameters of the model allows us to conclude that the determinate influence for the analyzed period was extended by the macro environment, fluctuation and social political environment, economic factors that enterprise cannot influence, but to which they must passively adapt. Step number 3, it is development of recommendation of the economic behavior of an enterprise. In order to form an effective decision-making support system and to analyze how the economic behavior of enterprise will change in future under the influence of factor of the macroeconomic environment and the immediate economic environment, it is possible to analyze the indicator of economic sentiments. It is a comprehensive assessment of 15 standardized, seasonally adjusted indicators, 11 of which are components of the business confidence indicator in industry conclusion, construction, retail trade, the service, and 4 are components of the confidence indicators. Slide 7 shows by dynamic of change in this indicator for the period 2017-2023 in a quarterly section. This graphic shows that 2 characteristic stage can be destruction in the economy of Ukraine. The first stage of stabilization from first quarter is 2070 to first quarter of 2020 is characterized by a steady trend and gradual increase in business activity of the economic market. This means that when forming the economic behavior in the economic space of country, enterprise of various types and economic activity should use various opportunities for the development of our business. The second stage of weight fluctuation from second quarter of 2020 to second quarter of 2023 is characterized by high volatility of economic process, which were provoked by in the COVID-19 pandemic, second quarter of 2020, and Russian aggression in 2022, second quarter of 2022 years. This is a stage of significant change in the exploitation of Ukrainian enterprises, which could not be influenced on passively adapted to such turbulence. Provided this the indicator of the economic sentiment reflects general economic expectation regarding business activity in the country's market. It is proposed to use it is a correction factor when forecasting an integral indicator of the macroeconomic environment. Slide 8 presents a portrait of changes in general economic exploitation of Ukrainian enterprise for the critical years 2017, 2020, 2022. As we can see, the biggest drop in the business activity is observed in the second and third quarters of 2022, which was provoked by Russian military aggressions. The external environment of enterprise not only did not create opportunities for business development, but on the contrary formed significant barriers for their functions. However, different types of economic activity reached with different to general economic changes. Slide 9 shows by dynamic of indicators of business confidence for types for economic activity, namely industry, construction, retail trade, and service, which make a dominant contribution to the country's GDP. In the slide 9 shows the hierarchy of sensitive of types of economic activity to price fluctuation of the external environments. Thus, the most sensitive types are construction and service sector. The drop in business activity in the second quarter of 2020 was by 45.6 and 38.6 respectively. In the second quarter of 2020 years, it is 69.7 and 50 2.4 respectively. The last sensitive are industry and retail trade. It is second quarter of 2020, 10 and 4 respectively, and second quarter of 2022. Considering that the indicator of business confidence reflects the sensitive of various economic activities to fluctuation in the general external environment, it is proposed to use it is a correction factor for the integral indicator of the intermediate environment. Thus, the development algorithm models of studying the complexly structured and internal environment of the enterprise south the decision-making support system will allow to form achievable and effective scenarios of the economic behavior of the enterprise, of the corresponding types of economic activity, and maintaining the stability of its development attractors. Thank you for attention.
Thank you for presentation. Next presentation, dear Muhammed Usame Özic.
Yes, I am here.
Yeah, you can start.
Okay. Okay, dear listeners, I will present to you our paper entitled An Approach to Classifying Breast Density Level Using Deep Learning-Based Segmentation Model on Full-Field Digital Mammograms. My name is Muhammed Usame Özic. I am currently working in the Department of Biomedical Engineering at Pamukkale University. We carry out this study with our undergraduate students Ayşe Sidanur Yılmaz, Halil İbrahim Sandıras, Baha Hilmi Estanto. This presentation presents you the outline of the study, introduction and data set, pre-processing and image annotations, YOLO V8 network settings, training and testing results, Weigel results, discussions, and references. Breast cancer is one of the leading causes of the cancer-related deaths among women. In 2020, more than 2.3 million breast cancer were diagnosed worldwide, and approximately 685,000 deaths occurred due to the breast cancer. This rate corresponds to approximately 1 in every 6 female cancer deaths. X-ray based mammography images are mostly used clinically in detection and analysis of breast cancer. Mammograms are taken from different views, as named full-field digital mammograms, left mediolateral oblique, LMLO, left craniocaudal, LCC, right craniocaudal, RCC, and right mediolateral oblique, RMLO. Using multi-wave images, radiologists perform mass detection, benign and malignant lesion detection, analysis of suspicious areas, and evaluation of many other findings. The images below show mammography images from four different angles. Our problem and general problem, diagnosis of breast cancer can often be difficult due to the complexity of the disease, similar pattern areas in radiological images, especially breast density, and dissimilarity pixel patterns between benign and malignant tumors. Breast density is a structure that determines the ratio of glandular and connective tissue in a woman's breast and directly affecting the assessment of breast cancer risk in radiological images. Since dense breast tissue directly affects imaging results, it causes the need for examination and delays in early diagnosis. As you can see, this figure, this is non-dense breast, especially you can clearly see in the lesion, and the other denser breast, as you can see, a large cancer is hard to see. Breast density assessments or level is divided into 4 categories: fatty A, sketched density B, heterogeneously dense C, and extremely dense D, according to breast imaging reporting and data system BIRETS. As you can see, this figure, category A from view RCC and category B from view RMLO, category C from view LCC, and category D view from view LMLO. In this study, we used the YOLO V8 deep learning segmentation model to assess breast density into 4 classes: A, fatty, B, sketched density, C, heterogeneously dense, and D, extremely dense. We didn't apply any complex pre-processing methods, and we didn't remove the pectoral muscle from the images. Especially in RMLO and all LMLO images, the pectoral muscle is separated from the breast tissue by a thin line, as you can see this figure, and can be seen as a different structure with relatively light tone density pixel values. Our data set, we used the Winder MAMO, the WinDR MAMO data set, an open source data set of full file digital mammography images we used in the study. The data set contains 20,000 multi-view images from 5,000 patients with information on laterality, findings, view, image size, BIS category, and breast density category. A random data set of 1,200 images was created from WinDR MAMO with a full representation of views and densities within the 4 breast density categories, except for category A, for which very little data was available. These are data sets we created, and distribution of breast density categories are created data set according to 4 views. We used the YOLO V8 deep learning algorithm in this study. This algorithm that has recently been popularly used for segmentation, detection, pose estimation, object tracking, and classification applications. In this study, since it is a state-of-the-art algorithm, especially the segmentation model of this model we used. Pre-processing and image annotation. DICOM format images were converted to PNG format using a DICOM viewer firstly. Images were 2,800 by 3,518 in size and 8-bit resolution. Annotation was performed with the polygon option using the label beam program. Breast areas were labeled in LCC and RCC views, and breast regions were labeled in RMLO and LMLO images, taking into account the areas where the pectoral muscle was absent. Polygon labels were converted to YOLO formats and served as text files. These are YOLO V8 network settings. Firstly, UltraDix framework was used for training and testing the YOLO V8 model. So we download this framework our computer. Training and testing were performed on Google Colab Pro cloud environment, which provides GPUs, especially high GPUs. Parameters of the model were optimized using stochastic gradient descent with a mini batch size of 16 and 600 epochs. YOLO V8M model were used due to the medium number of parameters. Pre-trained weights were downloaded and fine-tuned for this study. No additional data augmentation was performed because YOLO V8 automatically performs mosaic data augmentation. This presentation showed our training and testing results. Firstly, our data was randomly divided into 80% training, 10% validation, and 10% testing. YOLO V8M model was trained for 443 epochs on Google Colab Pro cloud environments. The trained model achieved high-speed detection performance with 36.4 millisecond inference time and high precision recall and FP score metrics on the test data as you can see in table 2 and table 4 and figure 3. These are visual results. As you can see, we can detect and segment especially breast areas, and we assigned a classification evolution category, and then we can separate exactly pectoral muscle with a thin line, and this is visual results for test mammography images in different views: red A, pink B, orange C, and yellow D. Results and discussion: YOLO V8 deep learning model with segmentation-based detection achieved high-speed performance with 75% precision, recall, and FP score on test data. The model can recognize images from different views regardless of the pectoral muscle in the RMLO and LMLO positions. Polygon-based labeling is a practical solution to include the exact breast area in training. Image pre-processing method can be used to obtain only the breast area with automatic or semi-automatic techniques to improve performance for advanced research. Thank you for listening.
Thank you for presentation. Do you have any question? Okay. Next presentation, dear Ramzi Kasım.
Hello, everyone.
Hello. You can start.
Okay. Hello, everyone. My name is Ramzi Kasım Mohammed. My paper title, Study and Analysis of BV System Behavior Disturbance. Presentation outline: introduction, research objective, system components, control circuit, system description, simulation, and result conclusion. Introduction: the environment is becoming a seriously concern due to the recent pollution caused by conventional producing unit run of fossil fuel energy, Many countries reversed the energy production policies by moving from outdated to more modern way of producing unit like renewable energy source. Although the RES renewable energy source system are designed to operate it regularly with a set of operational limits. They may experience disturbance that change how they operated and respond. The amount of electricity generated by renewable source varies throughout of the day to improve the reliability and security of the electrical power network. The ESS energy store system is essential to manage the power flow in the system. The energy management system EMS is required. The issue was critical in enhancing the security and efficiency of the microgrid. The efficiency and performance of PV hybrid grid connect system under disturbance and fault, such as a quick change in load or a rapid change in applied irradiation will be studies, analysis, and discussion in this paper. This is support system from MATLAB. Research objective: 1. To design and simulation and analyze the grid-tied PV system by using the MATLAB simulink program. 2. To investigate the design of the control unit for the step-up DC over DC converter to provide the MPPT as possible. 3. To design the control unit for DC over AC three-phase inverter to provide constant output voltage and frequency. 4. To investigate the design of the control unit for bidirectional DC over DC converter of the battery. 5. To study the behavior of the grid-tied PV system with battery and during grid fault condition. 6. Analysis of the performance of the battery during different disturbance and load and generated side. 7. Analysis of the performance of the PV system during different irradiation and temperature. 8. Compute the MPPT efficiency for different logarithm. This is system 0.3 system component. The PV system and boost converter, battery system, bidirectional converter, DC link capacitors, a three-phase inverter, LC filters, load, and a grid. This is MPPT and the drop controller. PV system, it is comprises of the PV generated system with 20 cross 50 centish power module PLUT or 250 watt diameter panels to produce roughly 250 kilowatt and 1000 ampere over meter square to raise the voltage to 800 at the DC bus voltage. The PV system is linked to the DC bus through DC over DC booster converter. Boost converter. A boost DC to DC converter is used to control the solar PV power. The boost converter operated in both MPPT mode and the voltage control mode. The voltage control mode is used only when load power is less than the maximum power generated by solar PV planet given the incident irradiated and panel temperature. Battery system, the battery energy system is used in emergency cases to store energy whenever the load demand is lower and the power generated by PV system, and to supply the load with the required power when the load demand is higher than the PV generated power. Bidirectional converter. The bidirectional bidirectional DC to DC converter block represent a converter that step up or step down DC voltage from either side of the converter to the other as driven by attached control and gate signal generator. The connection between the battery energy system and the DC bus is made via bidirectional DC to DC converter, which they use for both charging and discharging purpose. DC link capacitor. The DC link capacitor purpose is to provide a more stable DC voltage limit application, and the inverter for directly demand heavy current design can be used different technologies for DC link capacitor, such as aluminum, electricity, flame, and ceramic types. Three-phase inverter. The main advantage that three-phase inverter has over signal phase in that and can be transmit more power. A polyphase system itself will be produce power at constant rated with a load. The efficiency is also higher than in machinery that may be operated through a single phase. LC filter. The LC filter are specialty designed to reduce harmonic of current observed by power converter with rectifier input stage manually. They are mode of the parallel series combination of reactor and capacitor dependent to reduce to the THD, total harmonic distortion of rectifiers. And finally, load and grid. In solar terminology, the term load refers to the power contribution of the device that are being used in the system. Understanding your load is critical to maintain functional power system. A solar inverter or photovoltaic PV inverter is that can be fed into a commercial electrical grid or used by local off-grid electrical network. For controller circuit, bidirectional controller, DC voltage controller, and battery charging by using MATLAB. Three-phase inverter control by using MATLAB. System description. The proposed system by using MATLAB Simulink program. PV generation system consists of the 24x50 panels of synthetic power model PLU-TO 250 watt diameter to generate about 250 kilowatt at 1000 ampere over meter squared. PV system is connected to DC bus via DC to DC boost converter to increase the voltage to 800 at DC bus voltage. Battery systems connected to DC bus via DC to DC bidirectional converter. Three-phase inverter used to convert 800 volt DC to 380 volt AC voltage. The battery energy system is connected to DC by a bidirectional DC to DC converter. The bidirectional is used for charging and discharging cases. Three-phase inverter are used to convert the DC power at the DC bus to AC power that bus on VSG, virtual synchronized generator. generated is used in the work PF power frequency and QV reactive power voltage. Drop technique are used to improve the frequency response and the voltage stability. LC filter is important to make the output of voltage and current waveform pure and to reduce the harmonic. So number 6, simulation and result. The MPPT is method that use adjust PV area output power for varied operating environment and area configuration to get the maximum power. In this work, P&O MPPT is used perturbation and observation. P&O can be tracked the maximum power point MPP all the time, irrespective of the atmosphere condition type of PV panel and even aging by processing actual value of PV voltage and current. Proposed irradiation and temperature we can see from MATLAB sketch, and PV voltage current output we can see waveform from MATLAB. PV output during using MPPT and BO is shown in figure below. Efficiency and output power for P&O MPPT at irradiation of 750 watt over meter square. The efficiency can equal actual maximum output power over maximum rated power cross 100%. We can get efficiency 98.93%. The output voltage of the boost converter is shown figure below and is constant at 800 voltage during simulation time. The load balance between the generation power and load is shown in figure. For voltage current power of charging short SOC is shown in figure below. We can get path sketch from output MATLAB, battery voltage, battery current, state of charging, battery powers. When the fault occurs at the PV generation side, the protection system will be isolated. The PV system and load will be applied from the battery system. Figure below show the power balance when the fault occurs at T equal 5 seconds. When the fault occurs at the load demand side for few milliseconds from T equal 5 seconds to T equal 5.1 seconds, the power balance is shown in the figure below. PV system output power using P&O MPPT perturbation and observation when the dust reduce. The irradiation 5% is shown in figure below. The PV system output power using P&O MPPT when the temperature increased 20% is shown in figure. The PV system output power using P&O MPPT when the temperature increased 20% and the irradiation reduced by 5% in shown figure. This is output from system diagram MATLAB Simulink. The voltage and current before LC, a voltage and current after LC. voltage and current at load side. The total harmonic distortion THD is less than 5% and it is comply with the IEEE standard 590 for year 2040. The THD should be less than 5% for system with voltage less than 1 kilovolt. The frequency response during normal condition is shown figure below. Conclusion, point number 7, conclusion. In this work, the PV party integrated model was studied in detail with an energy management system. The proposed system is the 250 kilowatt is a quarter of 1 megawatt. Phase on of the well project that installed in the Ministry of Electricity of Iraq. The suggest system which comprises of the PV system battery energy storage system at the 3-phase inverter based on the VSG control strategy, available load, and the other power conversion device such output and bidirectional was simulated using the MATLAB Simulink software. The impact of the dust weather on the PV generation system is studied. The impact of the high temperature on the PV generation system is studied. The different faults are proposed in this work to ensure the energy management system operation fault at PV side and load demand side. The simulation results show that the P&Q MPPT technique has efficiency about 98.9030%. Thank you for listening.
Thank you for presentation.
Thank you.
You're welcome. Dear Anadolu.
Evet hocam. Sesim geliyor mu?
Geliyor. Başlayabilirsiniz.
Ben ekranımı paylaşayım hocam. Şu an geldi mi hocam ekran?
Geldi, problem.
Evet. İsmim Mehmet Ali Anadolu. Konya Teknik Üniversitesi'nde öğretim üyesiyim. Yüksek lisans öğrencim Burak Karaçam'ın tezinden hazırladığımız çalışmamızı sunacağız. Çalışmamızın araştırma konumuzun başlığı kar yağışlı bir bölgede işletilen mikro inverter ve dizel inverter teknolojilerinin performans analizinin karşılaştırılması. Çalışmamızın genel hatları, ilk önce problemin tanımı ve amaç kısmını anlatacağız. Sonrasında kullandığımız materyal ve metotları açıklayacağız. Sonrasında da elde ettiğimiz sonuçları sizlerle paylaşacağız. Fotovoltaik enerji üretim tesislerinde kullanılan panellerde inverterin ihtiyaçlarına göre ihtiyaçlarını karşılayabilmek, gereksinimlerini karşılayabilmek için paneller birbirleriyle seri şekilde bağlanır. Fakat bu seri şekilde bağlı olan panellerden birinin veya birkaçının ya da tamamının kar, toz veya bulut geçişleriyle veya çatılarda özellikle bacalarla engellenmesi sonucunda gölgelenen panellerden biri dizenin tüm enerji üretimi performansını düşürebiliyor.
Pardon hocam.
Efendim?
Slide devam ettirebilir misiniz?
Efendim?
Sadece ilk slaytı görüyoruz ama devam ettirebilir misiniz?
Şu an gelmiyor mu hocam?
Yok, sadece birinciyi görüyoruz biz.
Aa. Hocam pardon. Bir daha.
Şu an değişiyor, tamam.
O zaman şöyle hocam. Sunuyu aldım, oradan gelmedi demek ki.
Hı hı.
Şöyle geliyor mu hocam?
Şu an geliyor, problem yok.
O zaman böyle anlatayım hocam.
Tamam, olur,
Son
sıkıntı
ekrana
yok.
geçirdiğim an herhalde şey gözükmedi.
Olabilir, böyle devam edebilirsiniz.
Tamam, böyle devam edelim. Bu engellerin içinde de en etkili olanı kar yağışı. Bizim de çalışma konumuzun oluşturan kar yağışlı bölgelerde panellerin üzerinde biriken, özellikle çatılarda biriken kar birikintileri günlerce, belki de aylarca panellerin üzerinde kalıp üretimi tümüyle durdurabiliyor. Bu nedenle büyük tesislerde tek bir inverter yerine bu panellerdeki arızalı veya arızalı demeyelim, engellenen panellerin etkilerini azaltabilmek için string inverter veya mikro inverter yapıları tercih ediliyor. Bizim de araştırma konumuz bu kar yağışlı bölgelerde kullanılacak en uygun inverter veya panel teknolojisinin hangisinin olduğunun araştırılması üzerineydi. Bunun için de Konya Teknik Üniversitesi'nin kampüsü içinde bulunan bir tesis alanımız var. Bu tesis alanında iki farklı PV sistem var. Bu PV sistemlerden biri mikro inverter, biri ise string inverter yapısına sahip. Biz bu tesis alanındaki panelleri kış dönemlerinde dizelerin karşılaştırma yapabilmek için dizelerinden bir tanesini kardan sürekli temizledik. Mikro inverter sisteminde ise 6 farklı eğim açısında panellerimiz var. Her bir eğim açısında da 3 tane panel bulunuyor. Bu panellerden birer tanesini sürekli temiz tuttuk. Karşılaşma yaptırabilmek için, referans olarak kullanabilmek için. Bunlar tabii iki farklı PV sistem olduklarından dolayı bunların karşılaştırılabilmesi için literatürde de çok kullanılan bir tekniği kullandık. International Electric Committee dediğimiz bir kurum tarafından tanımlanmış standart parametreleri kullandık. Literatürde de genellikle farklı panel ve inverter sistemlerini kullanan tesislerin performansı için kullanılan ifadeler bunlar. Bunlar dize kazancı, nihai kazanç, referans kazanç, performans oranı, inverter verimliliği ve panel verimliliği olarak isimlendiriliyor. DC üretim verilerini, sistemdeki DC üretim verilerini mikro inverter ve dize inverter sistemindeki kullandığımız arayüz yazılımıyla mikro inverter sisteminde üretici firmanın sağladığı bir gateway cihazıyla dize inverter sisteminde de inverterin yazılım arayüzüyle bu DC verileri dakikalık ölçekte kaydettik. AC değerleri de gene aynı şekilde hem inverterlerin yazılım arayüzüyle hem de ana panolardaki elektrik sayaçlarıyla check ettik, kontrol ettik. Bu şekilde kaydettik. Referans kazanç için kullandığımız ışınım verilerini ise meteoroloji istasyonundan temin ettik. Sonrasında da bu değerleri bu tanımlanan performans analizlerinin değerlerine göre veya değişkenlerine göre değerlendirdik. Tesis alanımızda 30 derece eğim açısıyla yerleştirilmiş 36 tane panel var. Bu paneller dize inverterin iki farklı girişini besliyor. Bu dizelerden bir tanesinde 265 watt saatlik kurulu güce sahip 18 tane monokristal panel. Diğer dizede ise 10 tanesi 265 wattlık, 8 tanesi de 270 wattlık monokristal panelden oluşuyor. Yani ikisinde de toplam panel sayısı eşit. Fakat dizelerden bir tanesinde 270 wattlık 8 tane panelimiz biraz daha fazla. Kullandığımız inverter trafosuz bir inverter. Kurulu gücü, nominal gücü 10 kVA olan. Tesis alanındaki tesis alanını aydınlatmak için kullandığımız bir LED projektörlerimiz var. 2 adet. 70 wattlık. tesisteki verileri kaydetmek için kullandığımız bir masaüstü bilgisayarımız. Elektrik kesintileri sırasında da bu bilgisayarımızın enerjisinin devamını sağlamak ve tesis alanını aydınlatmak için kullandığımız 4 tane jel tipi akümüz var. Her biri 12 volt 200 amper saatlik. Ana panoda da biraz önce söylediğim gibi AC verileri şebekeye gönderdiğimiz veya şebekeden çektiğimiz enerjiyi ölçebilmek için de tek yönlü ve iki yönlü iki tane sayacımız bulunuyor. Teknik ve özellikleri hem panellerin hem de inverterin aşağıdaki tablolarda görüyorsunuz. Mikro inverter sisteminde de 0, 10, 20, 30, 40 ve 50 derecelik eğim açılarında güney yönünde yine sabit şekilde destek sisteminin üzerine, taşıyıcı sistemin üzerine montaj edilmiş panellerimiz var. Her bir eğim açısında 3 tane panel bulunuyor. Bu panellerin her biri 265 watt gücüne sahip. Bunun dışında başka bir çalışmada gene kullandığımız her bir eğim açısında 255 watt değere sahip yüzey ısıtmalı paneller var. Yüzey ısıtmalı panelleri bu çalışmaya dahil etmedik. Başka bir çalışmada verilerini kullandığımız için. Tesis alanında bir konteynerimiz bulunuyor. Bu konteynerin içinde gateway cihazından gelen verileri sürekli kaydettiğimiz ve bir data logger'ımızdan gelen verileri kaydettiğimiz bir masaüstü bilgisayarımız var. Tesis alanının bu kar yağışının etkilerini sürekli takip edebilmek, analizlerde de kullanabilmek için bir NVR cihazımız, kamera kayıt cihazımız bulunuyor. Yine ana panoda bir çift yönlü, bir tek yönlü olmak üzere 2 tane de elektrik saatimiz bulunuyor ki şebekeye gönderdiğimiz veya şebekeden çektiğimiz akım ve güçleri okuyup kaydedebilelim diye. Mikroinverter sistemindeki paneller 265 wattlık teknik özellikleri gene aşağıdaki tabloda verilmiş. Mikroinverterler de tek bir gövdenin içinde 2 tane PV girişi bulunan bir yapıya sahip. Yani her panel için ayrı bir inverter değil de her iki panel için bir tane inverteri kullandık. Fakat bunların çıkışları birbirlerinden bağımsız çalışıyor. Nominal güçleri 2 çarpı 360 dediğimiz, yani her biri 360 Watt'a kadar panel bağlayabildiğimiz sistemler. Şuradaki sol taraftaki tav grafikte string inverterin, sağdakindeki ise farklı eğim açılarındaki mikro inverter sistemlerinden elde ettiğimiz sonuçlar gözüküyor. Bu sonuçlarda string inverter sisteminde 2 tane farklı modül kullanmamızdan kaynaklanan grafiklerde de görülüyor. Dizelerden bir tanesi diğerinden biraz daha fazla enerji üretiyor. Fakat yıl boyunca bu enerji farklılığının hemen hemen sabit kaldığını gördük. Yıllık bazda baktığımız zaman dizelerden biri 9024 kWh elektrik üretti. Diğeri ise kar kaplı olan panelimiz, dizemiz ise 8294 kWh elektrik üretti. Bunları panel başına böldüğümüz zaman temiz olan panelde 501 kWh, kar kaplı olan iç temizleme yapmadığımız panelde ise panel başına düşen 461 kWh elektrik düşüyor. Temizlenen ve temizlenmeyen mikroinverter sistemindeki panellerde ise 0 derecede, 10 derecede, 20, 30, 40 ve 50 derecedeki değerler tabloda gösterilmiştir. Bu tablolarda şurası çok önemli. Bizim bu dize inverter ve mikro inverter sistemlerinde bizim string inverterdeki temizlenmiş olduğumuz paneller mikro inverter sistemindeki farklı eğim açılarındaki tüm panellerden daha fazla enerji üretmiş. Normalde dizedekilerin gölgelenme veya kar nedeniyle enerjisinin düşmesini bekleriz. Fakat bizim string inverterdeki monokristal panellerimiz mikroinverter sistemindeki polikristal panellerden daha fazla güç üretmiş. Yıllık anlamda ortalama panel verimliliğine baktığımızda yine monokristal panellerin temizlenenlerde verimin ortalama %15, temizlenmeyen kar kaplı olan panellerde yıllık verimin %13,2 olduğunu görüyoruz. Mikroinverter sisteminde temizlenen panellerde şöyle bir şeyi de fark ettik. Bazı aylarda özellikle kış aylarında kimi temizlenmeyen panellerin temizlenenlerden daha çok ürettiğini, bunun da çoğunlukla panellerin üretici tarafından bize verilen nominal değerlerinden daha fazla üretim yaptığını, bazılarının daha düşük yaptığını, dakikalık verideki veriler incelediğimizde de mikroinverterdeki bazı günlerde mikroinverterlerin maksimum güç noktasını yakalayamadığını fark ettik. Bu yüzden özellikle düşük eğim açılı olan 0, 10 ve 20 derecelik eğim açılarındaki panellerde verimin %16 gibi çok yüksek değerlere çıktığını da gördük. Ve kar yağışının temizlediğimiz panellerde verimin ve üretimin çok yükseldiğini, özellikle mesela mikroinverterlerde üretici tarafından belirtilen verimin %18 olmasına rağmen bizim hesapladığımız değerlerde bu düşük eğim açılı panellerde verimin %22'lere kadar çıktığını gördük. Yıllık anlamda ortalamaya aldığımız zaman bu değerler mikroinverter sistemindeki panellerde verimin yükselmesine neden olduğunu da gördük. Kar kaplı panellerde ise verimin %12 civarında, %13 civarında olduğunu gördük. Bu panellerdeki referans temizlenen panellerle kıyasladığımızda mikroinverter sistemindeki ve dize inverter sistemindeki kar kayıplarını hesapladığımızda dize inverterdeki kar kayıplarının %3,58 değerinde bir orana sahip olduğunu, temizlenmemiş mikroinverter sistemindeki panellerde ise bu kayıpların %3,5 ile %1,8 arasında bir değerler arasında değiştiğini gördük. Bu beklenen bir sonuçtu çünkü düşük eğim açılı panellerde kar daha fazla biriktiği için kayıpların da fazla olması bekleniyor. Fakat bizim 30 derecelik eğim açısındaki dize inverterimizde ise, string inverterimizde ise kar kayıplar, elde edilen kar kayıpları mikroinverter sistemindeki en düşük eğim açılı panelden bile daha yüksek çıktı. Bunun da nedeninin panellerin yerleşiminden kaynaklandığı. 3 sıra halinde yatay şekilde dize inverterde yerleştirilmiş olan panellerin arasındaki boşluklar panellerin üzerindeki biriken kar yığınlarının aşağı dökülmesine engel olduğunu gördük. Bu yüzden elde edilen kar kaybı mikroinverter sistemindeki sıfır eğim açısına yatay düzlemdeki bir panelden bile daha büyük bir kar kaybına neden olduğunu gözlemledik. Bu elde ettiğimiz sonuçları, ölçtüğümüz değerleri karşılaştırabilir sonuçlara dönüştürebilmek için performans ölçütlerini kullandık. Bunlardan bir tanesi referans kazanç. Referans kazanç panel düzlemine gelen ışınımın miktarı ile alakalı. Yıl boyunca 30 derecelik eğimli panellerde hesapladığımız ışınım değerini referans kazanca böldüğümüz zaman ve referans ışınıma böldüğümüz zaman elde ettiğimiz değerler 30 derece için 2124, diğer eğimli açılarda için elde ettiğimiz değerlerse 1829 ile 2124 arasında değişiyor. Bunların içinde bu bölgede kurulum yapılacak PV tesisler için en uygun eğim açısının bu elde ettiğimiz sonuçlara göre 30 ve 40 derece eğim açılarının olduğunu görüyoruz. Çünkü en yüksek ışının bu bölgede 30 ve 40 derece eğim açıyla yerleştirilmiş panellerde oluşuyor. Bu ışınımın yanında bizim dizelerden elde ettiğimiz karşılaştırılabilir sonuçlara dönüştürdüğümüzde Gene dize inverterdeki dizelerin hem kar kaplı hem temizlenen dizelerde elde edilen dize kazancının mikroinverter sistemindeki farklı eğim açılarındaki panellerde elde edilenden daha büyük olduğunu gördük. Yani daha büyük kar kaybı olmasına rağmen kullanılan monokristal panellerin daha fazla enerji ürettiği için bunu da ona bağladık. Polikristal panellerden daha fazla üretim yaptığını tespit ettik. Temizlenmeyen panellerde ise dize kazançları, yani gelen ışınımı DC enerjiye çevirme anlamında baktığımız zaman saat olarak yıllık anlamda gördüğünüz gibi en düşüğü 1398'lik bir değerle sıfır eğim açısındaki kar kaplı panelde elde ediliyor. Bu yakalama kayıpları olarak isimlendirilen, yani referans kazançtan RI kazancını, dize kazancını çıkarttığımız zaman elde ettiğimiz kayıplar, yani DC enerjiye gelen ışınımı dönüştürürken yıllık bazda saatlik olarak hesapladığımız kayıplarsa gene dize inverterde 248 ve 385 ki bu 385 değeri de kar kayıplarından kaynaklanan bir azalma, artma, fazla çıkmasının nedeni. Temiz olan yatay eğimli farklı eğim açılarındaki panellerde ise 73 ile 528 gibi büyük bir değer arasında değiştiğini gördük. Bunun da sebebi biraz önce de bahsettiğim gibi mikroinverter sistemindeki kimi paneller üretici firmanın etiket değeri, nominal değer, verdiği değerden daha fazla üretim yaptığı, hatta grafiklerde de göreceğiz. Kimi zaman gelen ışınımdan bile daha fazla üretim yaptığı tespit ettik. Yatay eğimli 0 derecedeki ve 0'a yakın 10-20 derecelik eğim açılarındaki panellerdeki kazancın neredeyse referans kimi günlerde, aylarda referans kazançtan bile fazla olduğunu tespit ettik. Bu inverter sistemleri şebekeye enerjiyi gönderirken kullandıkları inverterler sayesinde bir dönüşüm yaparak DC enerjiyi AC'ye çeviriyorlar. Bu elde ettiğimiz RI kazancını, dize kazancını şebekeye transfer ederken şebekede gönderdiğimiz saatlik anlamındaki kazanç değerimiz dize inverterde 1588 iken mikroinverter sistemindeki panellerde bu değerler 1712, 1759, 1746 gibi bizim dize inverterdekinden daha büyük değerlere çıkmış. Bunun da sebebini araştırdık. Biraz sonra onu da göstereceğim. Yani daha büyük enerji üretmemize rağmen dize inverterde şebekeye bu enerjiyi transfer ederken mikroinverter sistemi dize inverterden daha fazla şebekeye güç transfer edebiliyor. Bunu da performans oranıyla ifade ettiğimizde bizim dize inverterimizin performans oranının %25 olduğunu hesapladık. Mikroinverter sisteminde ise bu değer 0 ile 50 derecedeki açılar için %93 ile %73 arasında bir değerler almış farklı eğim açılarına göre. Performans oranının mikroinverterdekilerden daha düşük olduğunu görüyoruz burada. Bunun da sebebi dize inverter sistemindeki akülerden kaynaklanıyor. Çünkü akü şarj için gerekli olan enerjiyi fotovoltaik panellerden, gündüz fotovoltaik panellerden karşılıyor. Bu da şebekeye gönderdiğimiz enerjinin miktarını azaltıyor. Bu yüzden performans oranı dize inverterdeki sistemde mikroinverterdekinden daha düşük bir seviyeye inmesine, azalmasına sebep olmuş. İnverter verimliliği olarak baktığımızda ise inverter verimliliği bizim dize inverterde %85 iken mikroinverterlerde kar yağışlı günler hariç hemen hemen sabit bir şekilde gittiğini görüyoruz. %97 civarında. Kar kaplı panellerde özellikle Aralık ayında bu değerler %75 seviyelerine gerilemiş. Tabii büyük eğimli açılarda inverter daha büyük verimle çalışmış. Üzerinde daha az kar kaplı olduğu için. Batarya enerji depolama sisteminin ve akü enerji depolama sisteminin de sisteme etkilerini analiz edebilmek için bu sunumumuzda iki farklı günü seçtik. Biri açık gökyüzünün olduğu ve maksimum düzeyde elektrik üretilen 10 Mayıs 2021'i. Bir diğerinde ise kar kaplı panellerin birinin, dizelerden birinin kar kaplı olduğu bir günü seçtik, 19 Aralık'ı. Burada kar kaybı sıfırken dizelerden bir tanesi o günde 36.406 watt saat elektrik üretirken temizlenmemiş olan veya temiz olan, gerçi ikisi de temiz de temizlememiş diye isimlendirdiğimiz için bu şekilde hitap ediyorum. Diğer dizem ise 34.880 watt enerji üretmiş. Bunun 1982 watt saatini aküyü şarj etmek için kullanmışız. 1135 wattını ise sistemdeki LED projektörleri ve bilgisayarı beslemek için kullanmış akülerden ve şebekeden. Şebekeye transfer ettiğimiz enerji ise 60.490 watt saat. Kar kaplı günde ise üretilen enerjinin, yani dizelerden biri kar kaplı olduğu için %93 bir kayba neden olmuş. Bu kar kaplı hemen hemen sıfır seviyesinde, zaten diğeriyle kıyasladığımız zaman çok düşük bir seviyede. Üretilen enerjinin 5980 wattını temiz olan panel, 395 watt saatini ise kar kaplı panel üretmiş. Bunun 1250 watt saatini aküyü şarj etmek, 531 watt saatini bu LED projektörler ve bilgisayar için kullanmışız çıkışımızdaki şebekeden. Şebekeye transfer ettiğimiz enerji ise ölçtüğümüz değer 2990 watt saat olarak kullanılmış. Yıllık bazda baktığımız zaman akünün bu şarj için, PV'lerden şarj olmak için kullandığı enerjinin 691 kilowatt saat olduğunu, bunun da yıllık enerji üretiminin %4'üne karşılık geldiğini tespit ettik, hesapladık. Bu oranla baktığımız zaman biraz önce verdiğimiz kar kayıplarına nazaran akü sistemi veya enerji depolama sistemi yıl içindeki karın neden olduğu kayıptan daha fazla kayba neden oluyor. Yıl boyunca ürettiğimiz elektriğin 14.878 kilowatt saatini şebekeye, 333 kilowatt saatini ise inverterin çıkışındaki bizim bilgisayar ve aydınlatma sistemini beslemek için kullanmışız. Bu sonuçlara göre bizim akü sistemi sürekli şarj edildiği, PV'lerden şarj edildiği için akünün yönetim sistemine göre sürekli şebekeye transfer ettiğimiz enerjinin miktarını düşürmektedir. Sonuçlara gelirsek, bu çalışmamızın sonucunda bu iki sistemi karşılaştırdığımız bu iki dize ve mikroinverter sistemindeki panellerin enerji üretiminin panellerin arasındaki uyumsuzluktan, yani üreticinin verdiği değerlerin altında veya üstünde enerji üretmesinden veya mikroinverterlerin maksimum güç noktasını yakalama problemlerinden ve kar kayıplarından kaynaklandığını gördük. Bunlara göre değiştiğini gördük. İkinci olarak mikro inverter sistemindeki kullandığımız polikristalle dize inverterdeki kullandığımız monokristal panelleri karşılaştırdığımızda bu bölgede daha fazla güç üretmek, daha yüksek panellerden verim elde etmek istiyorsak monokristal tabanlı panellerin kullanılması gerektiğini bulduk. Bu bölgede tesis edilecek PV sistemlerden yine yüksek kazancı elde etmek ve kar yağışının etkilerini azaltabilmek için panellerin kurulacak PV sistemdeki panellerin 30 ve 40 derece eğim açılarında kurulması gerektiğini tespit ettik. Bundan başka bu tür kar yağışlı bölgelerde enerji üretimini arttırmak ve kar yağışının neden olduğu kayıpları azaltabilmek için PV sistemlerde bu kar biriken, panellerin üzerinde biriken kar yığınlarının temizleme gerektirdiği ve bu bölgelerde daha yüksek kazanç elde etmek için bu temizleme faaliyetlerinin yürütülmesi gerektiği sonucuna vardı. Son olarak yıl boyunca dizel inverterdeki bizim akü grubumuzun veya yedek besleme sistemimizin sistemin sürekli performansını düşüren bir eleman olduğunu ve bu kayıtların şarj için kullandığımız kayıtların yıllık kar kayıtlarından daha büyük değerlere çıkabildiğini, o yüzden şebeke bağlantılı sistemlerde genellikle akü besleme sistemlerini yerine doğrudan şebeke ile sistemin çalışmasının daha verimli olacağı sonucuna vardı. Evet, dinlediğiniz için teşekkür ederim. Çalışmamızın sonuçları da böyle. Sorunuz varsa alayım.
Evet, sunum için çok teşekkürler.
Sağ olun hocam.
Okay, next presentation. Dear Faisal Ahmet. Dear Faisal.
Yes, I'm just sharing my presentation.
Okay. You can start.
Hello, everyone. I'm Faisal Ahmed. I'm a graduate research assistant of system engineering from University of South Alabama. At the first, I would like to give thanks of this committee and this conference. Today, I'm going to present our paper on virtual patient in medical education. So at the first, I would like to start with some background actually. So immersive technology just introduced around 1950, but nowadays we are using the immersive technology. This is a bit differences from the previous one. Nowadays we are using various type of immersive technology such as virtual reality, augmented reality, mixed reality, extended reality, and some others in various fields of our everyday life, such as gaming, entertainment, training and simulation, education, healthcare, and etc. So nowadays we can use this type of immersive technology in various sector such as our cultures and ideas generation and everything. So the aim of this paper will be basic understanding on the core concept of immersive technology, virtual human and gamification. A reader will get the concept of virtual patient and its structure, as well as they will understand how virtual patient can be employed in teaching. So here I would like to start about immersive technology. So the first immersive technology came to human era. It was virtual reality. The history was around 1950 when the military just used various type of simulation to train their pilot. But nowadays we are just using various different type of virtual reality. Most of cases we can use a head-mounted display where user can experience the 3D environment. But here we do have a limitation of this type of immersive technology. In this case, the whole physical world just convert to the digital world, but the user can't interact with the physical world, but he can interact with the digital world. So to overcome this type of limitation, the augmented reality came. So the first augmented reality came at 1968 through the father of computer graphics. But this augmented reality was more faster that is time. So it just become it's become famous in recent decade. So what does actually augmented reality offer? So this augmented reality offer that interaction in real time, both physical and then virtual world. And if we put them together, then the concept of mixed reality came. So mixed reality is nothing but to virtual reality and augmented reality under an umbrella. And in some and the extended version, we can experience of extended reality where user can just where user can define its level and various type of aspect of the immersive technologies. So this all type of this four type of technology do have some still limitation, which just make a researcher interest to introduce the virtual human. So those four type of immersive technology I have shared before slide, they actually don't behave like real human in aspect of behavior, interaction, real-time interaction, facial expression. So here researcher took the virtual human here. So what can virtual human do? So virtual human is something like 3D animation. It might be some 3D animation, might be avatar. So who just seems like the human in behavioral aspect. It can converse. It can make conversation with human, just like a human actually. Meanwhile, it can process the natural language, which is we call NPL, and it has some emotional. It just act with some emotions and and with some facial expression as well. And in addition, that virtual human can make conversation like some ethical aspect or non-ethical aspect, and user can set their preference in virtual human in differences level. Say for example, if a student of at standard 5, we can just make virtual human at their level, whereas we can make virtual human at standard 11 in some other cases. So this type of differences virtual human offer from the previous type of immersive technologies. In these slides, we are going to see a very interesting tool, which is named as gamification. So gamification is a kind of tool that make the non-technical education that make the non-gamification item or non-gamification topic more interested. So there are some element gamification have which just offer like something like badges, avatar, quizzes, and storytelling, which just make the topic is more interesting for the learner. So actually, what does gamification offer, and what type of impact gamification does have to make the topic interest? So if we put this gamification element to a non-game topic, it will increase motivation. When gamification in education increase students' motivation by providing immediate feedback, rewards, and a sense of something like accomplishment. And when the student will interact with the topic through their teacher, so they it's just a result of it will just something like result in active learning. It encourages active learning and participation, as students are more likely to engage in tasks that are presented as challenges or something like this. And through the gamification, it can be tailored to individual learning style, pace, and making it suitable and diverse to the learners. So through the gamification, we can make the topic customized for different type of different tier of learners. As gamification just make the interaction higher to the learners, so it becomes a significant tool for a critical type of problem solving, critical thinking, and decision making. And as a result, the competition and the collaboration just take place among the learners, and it might take some leaderboards or team-based challenges, which seems to healthy competition collaboration. So all of this important thing we can do with gamification, which just make the education such as immersive technology in various learning sector make it's um, very smooth to the learners. And when the learners got involved with their topic, so at the end they got satisfied with their topic, with their learning process. So here is the core concept of virtual patient. Actually, the concept of virtual patient came from the limitation of the real patient. So in medical learning, learning through a patient is very important. So when medical students go through some medical college or hospital to visit their patient with their professor, so at that time there are some issue with issue got generated with patient safety and trial and error learning. As we all of know that trial and error is a very common practice in teaching and research profession. So when we are going to when the students is going to work with the real-time patient, so at the time trial error is not possible, because if we go through trial error process, it might be risks of the patient. So and as a result, the learning is not will not that good enough. So the core concept of virtual patient just came from the differences from the real patient and the benefits of virtual patient. So this is the features of virtual patients here. So in virtual patient, we got more interactivity from the real patient, and in virtual patient, the clinical information request response is much more higher than the real one, and the feedback we got from the virtual patient is more realistic, and they can answer properly. And learner collaboration is too high, and when the students can assess this virtual patient very easily in very easy method. So actually, what are the benefits of virtual patient in medical sector actually? So first here it came safe and ethical environment. Say for example, a branch of student went to a medical college to practice or to just go through some case study in various type of patient. So in most cases, the patient might not give the right to give some experiment on him, and if the student do so, it might not be ethical and might not be safe actually. So when we just take here the virtual patient, so the accessibility to the virtual patient is much more higher, and here they can experiment different type of cases. Here they can practice different type of issues, which is much more safe with the environment. And about the reproducibility, virtual patient can replicate clinical scenarios, various type of critical scenarios, which they can get from the same type of experience from the real-time operation. And the reproducibility mean the same type of case virtual patient through the virtual patient we can generate it repeatedly and repeatedly. So here is no issue to make disturbing the real patient. And diverse clinical case, this is something like through one virtual patient the student can access various type of cases through one actually virtual patient. And the accessibility, so as it is a technology, this is not a real human being, so student can access it at any of the time as per their schedule. And the interactivity with the virtual patient is much more real, because most of the time when the patient condition is not that good enough, he might not give the actual feedback, or he might not give the actual interactivity with the students or learners or researcher, but virtual patient can give the exact scenario of his condition after some experiment, after some practices, and the realistic and the feedback will be the realistic one. What will be the time and cost? Yeah, so a branch of student, if go through the real patient through some medical college, so they might not get all type of case in a single time or in a single schedule, because this is rare to get all type of case at a time. But when it comes to virtual patient, they just set up what type of case they want to go through or they want to practice. Then at that time they can practice different type of cases. So here the time will be taken the less, and the cost will be the minimum. And about the research, when the researcher would like to go some trial and error basis, so it will be much more safe to work with a virtual patient than a real human being. So this was the all benefits of virtual patient in medical education. Any question, please?
Thank you for presentation. Any question? Okay. All presentations are completed. You can download your certificate from paper management system.
Sorry, I didn't get the last one.
Yeah. Okay. See you at next session.